Hi there, Doug from BrainGrid. One of the greatest features that have come out of the AI revolution are agents that help developers and those who don't know how to develop code applications. And these tools allow people who don't know how to code start from scratch with just an idea and come up with the finished product. One of these tools is Cursor. And Cursor is an IDE. It's a development environment that's based on VS Code, which is something familiar to a lot of developers. It's built to work with agents first and have the work with the agents. So you just type text, talk to the agents, and the agents will write your code. It begins looking like a basic IDE, but you come up to the corner and you click agents, and all of a sudden you have an agent here who you can chat with and describe what you want to do and how the code can get written. Now, that's amazing. Cursor has all of the context of all of the code in your GitHub repo, helping you develop. But one thing that happens when you're a developer is that not all of the information is in your repo. There are probably issues on GitHub. There may be databases that your code interfaces with, and when you ask the agent to interact with that database, it makes up the table name, or it doesn't quite have the right column. And so the queries aren't quite right, and you have to go back and fix those. You might be interacting with an API, and it just puts in placeholder information. One thing we can do is we can add MCP servers, a model context protocol. Let's work out what an MCP means. The model, the LLM, has a context, and this protocol helps expand that context to other bits of information. Here in this code, I've added Supabase, and so that means that if I have my database is on Supabase, now when I talk with my agent, it has the context of my databases. I could add in APIs. I could add in GitHub. Cursor has a lot of MCP servers that are available. So here's Notion, so you can get your notes, Figma for maybe designs, Vercel so you can launch it. The list goes on. There's lots of different ways you can integrate and give your LLM that you're coding with more context to what you're trying to bring to light inside your application. So let's install BrainGrid into Cursor. We start off in the documentation where we work to install with Cursor, and we follow the installations to install the CLI, the command line interface. I've already done this. I'll put a link in the description below so you can see how to do this, but it's 4 commands. You install it from npm, you log in, you initialize your repo to BrainGrid, and then you set up Cursor. The next step is to set up the MCP. So we go to the installation guide, we choose Cursor. So all we need to do to install that is we're going to click Add to Cursor, and it says over here in the Cursor settings, it says you want to install the MCP server. With the settings, we say yes. And now it says it needs authentication, so we click Connect. That opens up the browser where we say go for it. And now we have BrainGrid installed as an MCP server inside Cursor. And we can see the 18 tools that have been installed. Today, my to-do app only stores my to-do list in memory. So if I reload the page, it's gone. If I put a to-do list on my computer and try to open it on my phone, it's not there. So I want to add backend storage. So I want to add a Supabase database that's going to hold all of my to-dos and delete the ones after I'm done with them. So I'm going to create a requirement to create that Supabase backend. I want to use this branch that's been migrated to Next.js, and I want to create a Supabase data store for my to-dos and their completion status. If a to-do is deleted, delete it from the database. I've chosen the project. I've picked the branch that I want to build off of, and we're going to ask BrainGrid to create the requirements. After a few minutes of spinning on my specification, BrainGrid begins asking me some clarifying questions. So what do we want to store in the to-do? Well, we want the title description. We want the completion status. Let's add these, a completion, when it was created and the due date. And if we want, we could add a priority too. Should to-dos be associated with specific users? We're just going with a single user. Authentication is a whole nother ballgame that we just don't want to deal with for this requirement. When the user clicks the delete button, it should be deleted, permanently removed from the database, and we should just delete it. And now BrainGrid is going to churn on this added information and come up with requirements for the feature. A couple of minutes later, we get the requirements documentation, similar to the docs that a project manager might create. So here's the overview. We're going to add this persistence layer in Supabase, replacing this, the state management with cloud-based storage. So we don't, here's the problem, we lose our to-dos. So we're going to add a Supabase integration with the Postgres table, real live updates, an API to be able to go back and forth between the device and the database. We've got a data model, and we added all these other things with the priority model and the due date, all these other things. Data integrity. So we're going to create a database, integrate it with the Supabase client, create the API endpoints, right? So to create a to-do, read to-dos, update to-dos, delete to-dos, and then, real-time subscription so we can update, and then errors, error handling in case there's a network error or a validation error, etc. And then stuff that we deferred, user authentication, we will add those later if we need to. Archive, the stuff we decided not to do, and then it created a bunch of acceptance criteria. I'm just going to say this is okay. If there's actual real development for my application, I'd probably give it a really solid look, but this looks pretty good to me. So I'm going to accept all. And then it says, do you want to break these down into implementation tasks, or do you want to refine anything first? So it's like, let's just make the tasks. And so now BrainGrid is going to take those requirements, look at the code, and create a set of prompts and tasks that Cursor can use to then do the development work. A few minutes later, BrainGrid has come up with 6 tasks, and you can see they're all right here inside the BrainGrid tool. These are all now ready to be run inside Cursor. So we're going to flip back to Cursor and use the BrainGrid MCP to accomplish these tasks. We'll notice that this is project 3, request 6, and then there's 6 tasks. So we're going to use the /build command, and we're going to say this is project 3 and it's requirement 6. Cursor has logged into BrainGrid, it got my requirement, and it's found these 6 tasks. And it says, if you'd like, I can now start implementing these tasks in the code base step by step. And within a few minutes, Cursor has completed implementing those 6 tasks that I gave it. Now, of course, this is a very simple project. You might have gotten away with using Cursor alone to implement this, but using the spec-driven development of BrainGrid makes it much easier. BrainGrid helps flesh out the idea, asks you questions on how you want it to look, what you want to have happen in the back end, and maybe gives you ideas of things that could be added. In this case, it asked if I wanted to add start date and end dates and priorities. I thought, hey, that's a great thing to add to the application. It then was able to create the tasks in such a way that they were prompts that could be used directly by Cursor to create the code. So MCPs provide an valuable added context to Cursor, helping you build faster, more seamlessly, and with fewer errors. It's really exciting to see how AI agents are changing the way we code, and the addition of MCP servers makes it even easier. Thanks for watching.